All right. In the last video, we waded through chapter 10, which is a much more complex chapter in terms of application and underlying theory. And while the muscle chapter and the bones and the joints may seem like there's a lot of detail to remember, that's actually able to be memorized, whereas chapter 10 falls into that category of application and works in conjunction with chapters 10 and 11 in Fundamentals of Therapeutic Massage. So what I want to do in this video is show you how to work chapters 9 and 10 together to consolidate and support learning of this material. So I'm going to bounce back between the two chapters. I'm going to use an example, and that you can then use as a pattern for all of the body areas. So I picked out a relatively simple joint structure function for this explanation. Primarily functions just on one plane. There's also other movement with it, but we're going to look at the knee joint and we're going to compare that and we're going to use that as a way to say, okay, so here's the information you find in chapter 10. Here's how you expand on that in chapter 9. And now here's how chapter 10 makes more sense. So that's what we're going to do, I hope. Okay, share the screen. All right, so let me get this thing out of my way. All right. So here is the chapter 10. This is one of the activities. This one happens to be about knee flexion and extension. So if you start in chapter 10 and you find a picture that you want to learn about, so we're going to learn about this knee movement. And this movement should be incorporated into part of the general massage, which then becomes assessment. So the flexion of the knee should be from 0, which is out flat. This one's at 0. This is the opposite leg. And this one's bent to 90 degrees and a little. 90. There's your 90. And it's a little bit past that, which is functional movement that's appropriate for a hinge joint. So this would be seen as 0 to 90 plus. And then when we look at extension, that would be seen as 90 plus to 0. And all of this starts from anatomical position. So all of these pictures become examples of the joint movement. Okay, now, as we get to these activities in chapter 10, the application, along with learning how to position and what muscles are involved, is also some very simple muscle assessment for whether or not the muscle can produce the movement, the muscle structures can produce the movement, a hold against resistance. And will the opposing group, the antagonist, control smoothly and allow the movement of the agonist. So that's explained here in the beginning. Okay, that's what these arrows are. So we're not going to pay a whole lot of attention to those arrows just yet. We're going to look at this description for this picture. And for the most part, in chapter 10, these activities are organized in agonist-antagonist relationships, or a functional movement pattern around a particular joint. So you can see as we move down here, now we're going to look at knee extension. So, and then there's the picture. Now, this picture happens to be with somebody seated. That doesn't mean you can't still do it on the table. This was just to try to give, the positions we chose were to try to give the best visual on this. So you study these in functional units. The same thing would be for shoulder internal and external rotation, or cervical flexion and extension, or hip abduction and adduction. So what you find here when you're looking at this is that you've got a list of main muscles involved here. So we've got the hamstring group that would be in the posterior thigh, and we have the popliteus and the gastrocnemius that would be probably described more in the lower leg. So we can look up these muscles and learn more about them, which is what we're going to do. Then we can look here. I gotta make this a little bigger. And we can identify what the range of motion is. And I still can't see that. So you're gonna watch me put on some funny little reading glasses. Okay, that says 0, which means it's starting from the anatomical position, which would be extension, and flexing to as much as 150 degrees. Which is much more than what I have initially indicated as what's needed for functional movement, which 90 and a little. So if you've got anywhere beyond 90 degrees within the knee joint in flexion, and the ability for it to go back out to 0 without any limitations or pain, you're doing fine. This would be the end of it. This would be the most range you could get. And you don't usually want to assess at end range. Then it tells you how to position the client. And then it's going to tell you how to assess this. So the blue arrow is the direction that the client is moving. Let me get this down again. So whether I am moving the client, therapist, or the person is moving it themselves, which would be active, this is the direction it's going, and the muscles producing knee flexion are acting. They are concentrically acting to pull. And then if I wanted to apply a resistant force or a counter force to see if these muscles are strong enough to hold that, then I would try to bring the leg in the opposite direction. I'd try to get the knee to move into extension. So this particular video is not about muscle testing per se, but it's important to understand what these arrows are about. So once we get it into the position and we understand what structures and muscles are producing this movement, then we can start to ask assessment questions like, okay, I know that the muscles were strong enough to move this body part from 0 on the table in this instance can lift its own weight to get into a flexed position. And then if I add a little resistance by telling them, okay, now hold that right there, and I'm going to gently pull this in the opposite direction. The key is gentle, gentle, just enough resistance. And if they can do that easily, then they also can produce this movement against a load. And that's what we want to know. Can they produce the movement, and then can they produce it with a little bit of resistance applied against it? If they can, that's good. Now, if they can't, and there's no pain involved, and it's just a little wobbly in there, then what I would suggest you do is do the massage session, the whole body. It's going to be not just local here, the whole body. Come back and assess again. Often that will somehow trigger the neural response that's going on with it. The muscles are not typically atrophied and unable to function. It's usually something in the nervous system. So if we do a full massage and move the body around, lots of times this will sort itself out. If it remains, then in chapter 10, in fundamentals, we have some muscle energy techniques, one in particular called pulsed muscle energy, where we as a therapist would hold the limb still here and have them move it back and forth, and it sends a stronger signal to the nervous system. If it still will not kick these in so that they can hold against a light resistance, a counter pull, and there's any kind of pain, or you notice any other motor function issues, then that might be an indication for a referral. Okay, so that's the arrows in the muscle testing. So what we want to do is go here and look, and we can get to know more information about the muscles that produce that movement when they act concentrically, when they actively pull. So I'm going to do that. I'm going to switch screens now. And we are in chapter 9, and we are looking here at muscles of the posterior thigh. And some of the muscles that we just read about are located in the posterior thigh, and some of them are located in the calf. So we did read biceps femoris, we did read semitendinosus, and we did read semimembranosus. And here's the short head of the biceps femoris. And we can see when we look at that, that these are global muscles. They cross two joints. They cross the hip joint. This is the group we're looking at right here, what we would call the hamstring group. But they also go and attach below the knee. So that anchoring right there below the knee allows it to grab onto the tibia for leverage. This would be like a third-class lever, and then it can pull that up. So here they are individually, and we'll come back and take a look at each of these. So flipping back and forth here now, we're going to look at an individual muscle. We've got the general overview here. And so we're going to look at biceps femoris. And let's go back. And yep, biceps femoris was one of the knees that produce, or one of the muscles that produces this knee movement. Okay. So, let's learn about that. So biceps femoris, and it's a two-headed, that's the bi, related to the thigh. Two heads, bicep, bi of the thigh. All right, comes down. All right, so now it's holding on to the ischial tuberosity here. So that's why it crosses two joints. So it can work at the hip, and it crosses below, comes over here on the fibula. So it can pull at the knee too. Works two joints. That means it's a global muscle. All right, so let's see what it says about it. All right, I'm going to have to put my handy dandy glasses on now again so that I can read. These are very fun. Okay, so the concentric action is when it pulls. And we're over in chapter 10, we were looking at knee flexion. And sure enough, flexion is its first action that is listed here. And it also can do a little bit of lateral rotation. So I had said to you that the knee joint primarily acts as a hinge, but it also can rotate in and out, back and forth. It happens when we're bending it, and then when we extend it so that the knee joint can lock and unlock. So we've got the entire muscle that does that, so that fits. So we know that this is the prime mover. Now, when this muscle is acting eccentrically, it's going to control both the rotation and extension at the knee. So just the opposite. And if it's operating isometrically, it is producing stabilization. So that's where the tone increases, but it does not produce movement. So concentric is actually going to pull, and it's going to produce knee flexion. And eccentrically, it's going to control extension. So when that knee goes back out, it's going to do it in a very controlled fashion. It's not going to just drop. So an eccentric action isn't just a total let go. It's a gradual elongation. And I'm not talking about the rotational parts of this for you to understand that, but this occurs in the rotational. So here it's lateral rotation or external rotation, and here it's medial rotation or internal rotation. So here are the attachments. We've got the long head and the short head are on the, it's the long head itself that is the two-jointed muscle. And the short head actually just works at the knee. So here's the picture. You can see that crosses the knee. But if we go down here and see the short head, where is that? Ta-da, ta-da. We'll find it up here. Here it is. It's taking most of its attachment on the femur and then functioning at the knee. So long head, short head. Long head, short head. Okay. So for the long head, the post-it, it sticks on at the ischial tuberosity and the sacrotuberous ligament. So it's definitely on the pelvis here. Origin, fixed, and proximal attachment. Remember, we have all of these. I like proximal attachment, but you'll see origin. And then it inserts both of them. But the short head here, lateral lip of the linea aspera, that's a kind of a sticky out line. The lateral intermuscular septum, that's a connective tissue structure. And the proximal above, 2/3 of the subcondylar lines. This is telling you that it's taking its attachment, its proximal attachment right on the femur. So you'd have to go back now and look at the skeleton to find all of these bony landmarks. All right. Then the insertion, or the mobile end, or the distal attachment, is on the lateral side of the fibular head and the lateral condyle of the tibia, and then also the deep fascia. And if it didn't attach onto the tibia or the fibula, it wouldn't be able to move the knee. Here are the nerves. So if you're having trouble with the muscle testing and it doesn't hold well, or it won't let go, it won't relax, the tone won't come down, then a neurologist or a physician might look to see what's going on with the innervation. And it is arising out of the sciatic nerve that exits from L5, lumbar 5 to sacral 2. Now, synergists are helpers. So if these are helpers of knee flexion, we should then also see them listed as muscles that work on the need to move it into flexion. So let's go see. If we see semimembranosus, semitendinosus, semimembranosus, and then gluteus maximus. Now that doesn't seem to make sense for it to work at the knee, but remember this muscle, especially the long head, crosses the joint, so it can also extend the hip and flex the knee. Let's go see if these other muscles are listed. Yep, there they are, semitendinosus and semimembranosus. So when the leg moves like that, it's the muscles of the posterior thigh, for the most part, called the hamstring group, that we were looking at over here in chapter 9. Now, the antagonist would produce the opposite movement. So if these produce flexion, then the major antagonists would produce extension. So if we go look at, again, chapter 10, and we get down here to where we are seeing knee extension, then we're seeing these muscles, rectus femoris, vastus intermedialis, vastus lateralis, and vastus medialis. So let's go see if those are what's listed. So it's the quadriceps group, and that's what those are for the knee. All those ones we just read are the quadriceps. And then we also have iliopsoas and tensor fascia lata, but those tensor fascia lata might function at the knee because it attaches into the IT band that goes all the way to the knee. But probably these two are more about hip extension or hip flexion, because hamstrings in general do the extension part. Then the tender trigger point area, an area that is commonly found that's tender and might be contributing to some shortening or some hesitation to move the muscle. It's in several areas. In the belly of the muscle, and also right near the joint. And so somebody might come in complaining that they've got some sort of issue in the back of their knee or the entire posterior thigh. And it might be even more when they flex their knee or they extend their knee. So now here's the other synergists here. Here's your semitendinosus. Now it's on the medial side. So when the biceps femoris and the semitendinosus pull together, you can see how they can lift that bone up. And same features here. The difference here is that when it pulls, it's concentric action. It still does flexion, but it rotates it in the opposite direction. And it also, when it's acting eccentrically, getting longer, slower, and controlling that when it goes from flexion to extension, then it's controlling the lateral rotation. And so in the medial and lateral rotation, biceps femoris and semitendinosus act as agonist antagonist to each other, but they work as synergists to flex the knee. And both of them, if they are contracting, producing little movement, are stabilization. And both, it would happen for both, the knee and the hip. Then we know where we want to look and see and touch. We want to look and see and touch where the fixed or non, the end that doesn't move very much, the origin, the proximal attachment. It's also on the ischial tuberosity. That's where you're sitting. And then the insertion, mobile end, distal attachment, is at the proximal anterior-medial tibia at the pes anserinus or ansiner. I always pronounce it anserinus, so I'm sure I'm killing that. Tendon and the deep fascia of the leg. So over here is where that happens, where that common tendon is at. And if we come up here and look at the picture of this, we can see that over here. And you've got multiple muscles that attach there. And you can palpate that, and it can be exquisitely sore. And that can give you an idea of which part of the hamstring, and another muscle that attaches there, sartorius, and another one that attaches there, gracilis, which is part of the adductor group. So if we really want to know how to pronounce that term, we're going to have to put it into a pronunciation key glossary and figure that out. So we've got, again, the helpers, and we've got the antagonists, and we looked and they match up. These are also functioning concentrically, and these would be, if the knee is flexed, they'd be functioning eccentrically. And then the common tender point areas that might create symptoms. And then we go on to the membranosus that is also on the medial side, and we have the same features. And then as you learn this, here are your drawings, to get that solidified. Now there were some other muscles there, but they didn't necessarily mention this adductor group. There's that gracilis that comes down. So those other ones must be on the calf, and they are. So we'll just continue down through here. Here now, what's this? These are the anterior muscles of the thigh. And these certainly would be our extensor group, extensors of the knee. So here's the rectus femoris, vastus lateralis, rectus femoris, sartorius is one I mentioned, vastus medialis. This shows you the compartment structure of that. So we just got done talking about the posterior compartment. And now this is the anterior compartment. These all work together. And then you've got your medial compartment. And then here's our knee joint again. And here's that combined tendon that was mentioned. So these would be the extensors of the knee. I'm going to go check that. And go back here and I'm going to look. So here's knee extension. And if I were going to muscle test this to see if it can hold, the person or the therapist would be taking the leg in this direction, which would move it from flexion to extension, and then apply a gentle force to see if it can hold that position. Oh, okay. So here are those other muscles. We've got with this, let's see. So here's extension. Nope, those other muscles aren't there. It was flexion that we had these. See? Gastrocnemius and popliteus. So we're going to have to continue to hunt down there for those. So these are all the quadriceps. Okay, we've got that. This is all extension of the knee. So we'll study those and draw those. So move your knee back and forth as you're thinking about this. Okay, now what have we got? This is the anterior and lateral leg. So we're thinking about the knee flexion. Knee flexion. It's gastrocnemius. We kind of know what that is. That's on the posterior part, isn't it? So we'd have to go hunt for that. And there's all your drawing activities. This is the lateral leg. So these are your fibularis muscles. None of those were mentioned. So those wouldn't be involved in flexion. Here we go. Muscles of the posterior leg. Okay, now we can see the gastroc, and sure enough, look what happens. They attach from the tibia all the way over the knee. They cross two joints. They cross the ankle, gastroc does, goes all the way up and attaches onto the condyles here. So there's our plantaris, there's our gastrocnemius. Now the soleus doesn't work at the knee. It only works at the ankle. You can see that here. This is going all the way up and attaching onto the femur. So the hamstrings come down and pull the tibia up, but the gastrocnemius can also do it if it needs to. And here's the popliteus. And here are our individual pictures now. And we'll take a look at this. So this is gastrocnemius. Gastrocnemius means belly of the leg. So when it is pulling, its actual concentric action, it pulls the toes down. That's its primary job. But it inverts the foot. But here it flexes the leg at the knee joint. Now its primary job is the first one listed, flexion of the foot. Down here, you see it's also got flexion of the knee joint because it crosses both joints. So that fits then with it being maybe not the prime mover, the one with the best mechanical advantage, like the hamstring group. But if something wasn't working right with that, and we're doing this muscle testing, and maybe it doesn't hold very well, and then somebody starts to get a cramp in their calf, well, it may be that this helper, this synergist here to the hamstring group, is working extra hard to help produce that knee flexion movement. And when it's functioning eccentrically, it allows for the ankle to go in the opposite direction of dorsiflexion and eversion, but it also allows extension of the leg. So sometimes if the leg cannot fully go into extension, maybe it's this helper muscle down here that is involved. So here's where they attach. Here's your innervation. So it takes a similar innervation as the hamstrings. And it says right here, it's a synergist to the soleus, which is primarily about plantar flexion, but also to the hamstrings. And it's an antagonist mostly to anterior tibialis, but also to the whole quadricep group. And then here is where you would find the common tender points and common symptoms down the posterior leg to the heel, into the foot, and can be a factor in knee pain. And that's often forgotten. So let's go back now and look at our movement here. So we understand about biceps femoris, semitendinosus, semimembranosus. Popliteus we didn't spend a lot of time with, but this is about you learning how to use this. Gastrocnemius we slowed down on. Popliteus crosses two joints, has a little bit of involvement with flexion. It actually is more involved in rotation. We know that at the end range, it can go as far as 150 degrees, but anything past 90 and a little is good functional movement. And we know how to apply a little resistance. So we know what flexion is. So we know all of the muscles that are with flexion, all the muscles involved in extension would be that agonist-antagonist group. So here are all your antagonists for flexion. But these then become all of your agonists or prime movers for extension. And then all of these become the antagonist. Okay, so we can look through all of these, and you see it's the range can go further. This is a little bit confusing on how they measure that, but it goes from 90, pretty much 90 to 0, which is your anatomical position, and then may extend 10 degrees beyond 0 if there's any hyperextension in the knee, which you really don't want. And then it tells you how to position the client, and then the movement. And then we get into the next phase, and we've got our plantar flexion. So that's down. In the standing position, I think of that as planting my toes into the ground. So this is how you go back and forth between chapters 10 and 9 to get a real understanding of function and not just the parts. And you can do this for every body area, just like this. And in the textbook, chapter 10 goes through the same pattern of learning about the area and the movement, and I think it's using internal and external rotation of the shoulder. Okay, so very helpful the way this is organized. And so you here, if we just go on through, plantar flexion and dorsiflexion are a functional muscle group, and they are agonist, antagonist to each other. You can then assume that if these are the muscles that produce the movement for dorsiflexion, that's bringing the toes up towards the nose. If these are the ones that are pulling, these would be functioning concentrically. And the opposing group over here, these that took it into plantar flexion, they have to switch. They have to switch from functioning concentrically to functioning eccentrically to allow that back and forth movement. And every single movement you see here, this would be your eversion and your inversion. Every movement that you see in chapter 10 in these activities should be automatically included into a non-painful active or passive range of motion of the client. And if we see that there is an issue, let's say we can't get the knee to go into full extension, it could be that these muscles aren't strong enough to pull, but it's more likely that these flexors here are not letting go. They're not letting the elongation happen. So if the problem is shortening or hypomobility in extension of this joint, extension of the knee, then we might need to go look at its opposing muscle group. It may be the flexors that won't let go, and vice versa. If a person has trouble flexing their knee, it could be that these muscles are not strong enough. That's what we would assess with the muscles testing. But that's not very common. it's more likely that it's opposing muscle group, the knee extensor muscles that are acting eccentrically as an antagonist, aren't doing that very well. They're not letting go of their concentric action. So this is a really efficient way of thinking yourself through this. And you want to talk yourself. Take my little glasses off here. I broke the lens and had to glue it on. Having a visual issue is lots of fun. All right, so now here we go. If you methodically, very methodically, take a look at this and do this, and we also mentioned that you would need to go all the way back to the bones on the femur to be able to identify some of those bony landmarks where that biceps, the short head of the biceps, was attaching, so that we can understand what that's all about. So it truly does swirl around, and the more repetition around that you give yourself, the better you'll retain it. And if you incorporate it into massage as a regular part of that, and you have this internal dialogue going on all the time, okay, when I do this action, the result is the knee flexes. And the muscles that would produce that action are the knee flexors. The knee flexors primarily are the hamstring group, but gastrocnemius and popliteus can help. But that's not their primary job. Do you see how you want to talk yourself through that? There was a little resistance to me moving that, and the client had to work kind of hard to flex their knee. I wonder if the antagonist group, the quadriceps, are not functioning very well eccentrically to allow that action to occur. And the more you repeat it, the more you say it, the more you apply that to a critical thinking meeting, the more critical thinking process, the more sense it will make to you. Okay, there we go.